All right, now we're going to try to identify multiple transformations at the same time. So there's going to be translations, dilations, all of it together. Ethan is going to add a brick walkway around the perimeter of his vegetable garden. The area of the walkway can be represented by the function f of x equals 4 times x plus 2.5 squared minus 25. Describe the transformations in the function, then graph the function. So, for me, I can see right away this is all based off of a quadratic. What's changing about it? There's three different things. There's this 4 getting multiplied on the outside. There's this plus 2.5 inside. And there is the minus 25 on the outside. So each one of those is doing something to this parent function. Let's go through them. For the yellow part, negative 25, that's on the outside of the squared, so that means it's translated down 25. The piece on the inside that I highlighted in pink here, that is a translation inside the squared, so we take its opposite, which would be negative 2.5, and that means to the left direction, so we're going to say left 2.5. And now with the 4 on the outside, that value 4 is bigger than 1, which means it's going to compress vertically. Compressed vertically. Now, if that was a negative 4, I would say it's compressed vertically and flipped over the x-axis, but it's not negative, so I don't have to describe any sort of reflection at all. All right, now we've described all of the transformations. Let's graph the function. Now, for something like this, even me, sometimes it's hard to just draw the translations out, particularly when you have something like it's translated down 25. That's really far down, right? So here, it might be easier to do some table of values. So I'm actually going to draw a table of values over on the side. X and f of x. Now, I'm going to pick some points out of convenience. I always like to pick the point 0. That's just a good one to have on my list. When I have 0.25 on the inside, I think, well, what do I add to 0.25 to make it 0? The additive inverse. Remember, that was a question that we learned in the first chapter, how to identify that. So I want to make sure I have negative 2.5 in there. So I'm going to have negative 2.5. That will make that center 0, which is pretty nice. And, let's just have negative 5 in there and maybe throw one other one down there, like a nice 2. So I'm going to plug these values into my calculator. And I'm just going to calculate them all real quick. I assume that you can plug these in your calculator. Be very careful about your parentheses here. So 4 parentheses, negative 5 plus 2.5, end parentheses, square it, and then subtract 25. And I get, oh, look at that. When I plugged in that 5 there, I got 0 as an output. Now let's do it again. Change that negative 2.5 into negative 2.5, and I get negative 25. Now I'm going to plug in 0. Itty stop. And, oh, I get another 0 there. That's nice. And let's plug in a 2. And I get 56. That's gigantic. That's probably not going to be on my graph. So let's try 1. And there we go. That looks like it might be something that I can do. 24. Now, an important part about all of these things is they're very, very large numbers for the outputs. So a normal y-axis isn't going to work. I'm going to make the y-axis go up by 5s. So 5, 10, 15, 20, 25, 30. That means it's going to go down by 5s as well. Negative 10, negative 20, negative 30. But for these numbers here, going over by ones is not too bad. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now I start plotting my points, and I'll do it in red here. No, I'll do it in blue. I've been doing them all in blue. So negative 5 gets me 0. Negative 2.5, so halfway there, gets me all the way down to negative 25. 0 gets me to 0, and to finish off the curve here, 1 goes up to 24, so just below the 25 line. Which means if I go just over to 6, it should be in the same position. And there I've got my graph. Nice rounded bit right there, and bring it on up. Now, one thing to notice on here, the compressed vertically part is not, oh man, I think it should curve a little bit more like that. There we go. The compressed vertically part is not very visible, but that's because we compressed the y-axis. We made every unit worth 5 units. So that's why that compressed vertically part isn't very visible. If we kept it as a unit for each one, it would have been huge. I would have had to zoom out. I would have had to do all kinds of weird stuff to make it happen. And if you plug it in GeoGebra real quick, might as well. This video isn't super long yet. GeoGebra. Let's go to the calculator and let's type it in. Y equals, actually it was f of x. It was an f of x equals 4 times x plus 2.5. And then we're going to square that one. Squared minus 25. All right, so there's my function. And you can see when I zoom out here, now it's much more apparent that it's compressed vertically. It is definitely super narrow, but if I zoom back in and grab my move graphics tool, put it on the y-axis, and shrink it down, so now you can see it's a little bit closer to what I was doing before. There we go. Now that looks a little bit closer to my graph, right? The one that I drew by hand. All right. So that is how you do a bunch of transformations at the same time. Sometimes it's hard to follow all of them. All you got to do is make sure that you make a table of values and plot it until you until I teach you more techniques to graph them quickly.